Ok, puteți porni prezentarea, vă rog. Ne auziți?
Da.
Era ok, se vedea adineori când ai dat share.
Așa e, da.
Oh, ok. Is it still visible?
Da, da, e ok, puteți porni.
Okay, nice.
Vedem prezentarea, poți să începi.
Excuse me?
Da, da, e ok.
Okay. My name is Sami Barbut-Dica. I'm a student in the third year at the University of Craiova in informatics. And today I want to present you a modern architecture for implementing an online judgment system, or as commonly known as an online evaluator for programming problems. In the current marketplace, there are plenty of such platforms, online evaluators. Some of them, as Bebe Info, are oriented towards e-learning, high school and Olympiad usage, gathering features like homeworks, classrooms management, and other kind of problems. There are also platforms like LeetCode for interview training for different companies, or platforms as CodeForces dedicated exclusively to preparing for online competitions in competitive programming. And the current solution I want to propose is a holistic platform called Pantheonics, which I want to develop in order to encompass some of many features, including both e-learning, interview training, or competitions based, in other words, a more general and customizable solution. In the current version of the platform, the main features involves a user management system where the user is able to create an account for managing his profile, avatar, and other personal data. Also, the account allows the user to access the problem archive, which in fact are proposed by a special set of users known as proposers, which propose problems, edit them. They can also add tests for the problems, test cases in format of zip archives. And then the problems are published towards the general usage of the other users in order to be solved. The problem solutions are submitted in plenty of programming languages. At the moment, the platform supports 10 programming languages, including C, C++, Rust, C#, etc. The submissions are evaluated by dedicated microservices, and the output of the evaluation is reported back to the user in almost in real time. Also, there are other targeted functional and also non-functional requirements for the current version of the platform, including, as I mentioned earlier, real-time code evaluation feedback. The submissions are evaluated in a secured sandbox because the users can also propose untrusted submissions, and they are isolated from the rest of the system while evaluated. The system should be highly scalable in order to support many users and many concurrent evaluation processes. Should the system also should be highly extensible and easily to be maintained. That's where microservices come into play. Also, the platform uses containerization technologies, and in this way, it can be provided as a multi-tenant solution to be used widely by users, or as a single tenant, in which certain clients or institutions can personalize and self-host instance of the platform and for their internal usage. Also, as I said earlier, the platform aims to support a wide range of programming problems, spanning data structures, algorithms, OP, databases, and etc. Regarding microservices, they are a common architectural paradigm nowadays because they promote agility. Each kind of service having a dedicated scope and solving a specific subdomain of the business of the systems. They're also small and focused. Each microservices is quite tiny and easily deployable. Also, microservices are highly scalable, as there could be both horizontally and vertically scaled independently of each other, depending on the usage scenario and data throughput. Each microservice owns its data, and they can also have different technology stacks aimed towards their specific requirements they're solving. Alongside microservices, a common used pattern is domain-driven design, mainly the strategic phase of the domain-driven design, in order to highly exploit the domain experts' knowledge in a project and extract the necessary requirements and ideas which could be easily used by the development teams in order to implement the microservices. In other words, the strategic phase of the domain-driven design gives us the main microservices and the main relationships between them. And secondary, also optional phase of the domain-driven design involves a tactical strategy, which uses several OP-related patterns in order to model each microservice. In fact, the current architecture of the platform of the Pentaonics uses currently a wide range of technologies and consists of a cluster of microservices involving 3 main microservices for the 3 main subdomains of the business space. And these are the authentication service, implementing the user in C# and the fast endpoints framework. The problem service, implemented using the ABP, also based on C# framework. And the evaluation service using Rust and its subsequent framework called Racket. There are also secondary microservices who supports the core ones regarding test management. The tests are stored in zipper hives on a bucket in Firebase Cloud Storage. And there are also Judge Zero instances. Judge Zero is currently a widely used solution for evaluating submissions in different programming languages. And the current architecture of the platform uses a set of such instances, which are load balanced using Nginx in order to be used by the evaluation service. There are also Envoy-based API gateway for exposing the REST API of the whole backend, and a web client implemented using the cross-platform framework Flutter. As I said earlier, there are plenty of technologies. Each of them having different and specific targets. For example, JAT0, as I said, is used for the code evaluation process. Rust is used for the submissions or evaluation microservice in order to promote a secure and fast evaluation. .NET is used for the authentication service because it promotes via the identity framework an easily way to integrate authentication based mechanisms and best practices using JWT and also OAuth in the future versions. Regarding of the containerization of the microservices, they're using Docker in order to declare the way each microservice should be run and deployed. Containers are more agile than the virtual machines because they're using the kernel of the host service where they are running. They're easily to be scaled, easily to be isolated from the other processes of the host system, and then can be orchestrating using tools like Docker Compose, which I currently use in the version of the project, or Kubernetes. In order to create a container from scratch, all you can do is write a Docker file like in the example using a YAML syntax, in which you declare the dependencies of the project and export several ports in order to be accessible by the other microservices in the cluster. Also, for the communication between microservices, I use Dapper as a distributed application runtime, which promotes best practices regarding service communication, point-to-point especially, state management for the services using caching like Redis or other solutions. It promotes publish subscribe patterns using message brokers and event streams as, for example, Apache Kafka. In fact, Dapper is an intermediary layer as it creates a mesh of services in order to facilitate the communication between different services using HTTP or gRPC calls. And these API calls promotes a loose coupling integration between each services. Also, it decouples the technology stack, the programming languages which microservices are implemented in, from the infrastructure of the system, which could be cloud or self-hosted based. And now I want to present a short demo of the platform. There's also a live hosted version on Firebase, and the backend is hosted on DigitalOcean. Let me close the presentation. Okay, is it visible? As you can see, currently the platform offers a list of problems to be solved. Let's try this one. Each problem consists of a description edited by the proposer of the problem in a Markdown format, and also different metadata, including the name of the problem, the source, time limit, memory limit, etc. The user can view in a list of submissions its own submissions for this problem, and can also propose its own solution. For example, in the Rust language, we can write in the editor of the platform code and send it for the evaluation. The evaluation is managed by a short polling process in the which is run in the evaluation microservices. Currently, the user should refresh the page in order to view the evaluation process, but in the future, I plan to use WebSockets for real-time communication. As you can see, the evaluation process reported back to the user the memory and the time footprint, the status, and also the submission can be viewed separately. For the sake of example, let's send a failed solution. Delete the semicolon and submit the solution again.
O să te rugăm, Sami, să încerci să închei, că am depășit cu mult timpul de prezentare.
Okay, just 10 seconds.
Yes, sure.
There are nothing else represented. And that's it. The response and the code evaluation. For the next version, I plan to introduce the contests and exams, OAuth 2.0 based authentication, and different kind of problems. And the presentation concludes here. Thanks for your time, and if there are any questions.
Okay, thank you. I would like to kindly ask you to limit your time to 10 minutes for the next presentation, because we are also in delay. We are in a delay. And if when you present technologies, you just need to mention them, not explain or details about them. And if you have an application, I say this for the future presentation, just start with the application. So just mention the technology, how you build it, and show us the application, because that is very important. We also have the presentation and the articles, and we can see for detailed information, but the application, if you have an application implemented, that is very important for us to see it. Okay, thank you, Sami. We will go to the next presentation.